Good morning to all. Now, I'm going to continue the dual nature of radiation and matter. This is very important chapter and very small chapter. I think today or tomorrow it may be complete. There are only few topics are there, and you listen very carefully. And now today's topic I am going to start now. In the last class we discussed about the photoelectric effect and experimental study of photoelectric effect we discussed. Now I am going to continue its that is today's topic is 1 minute. Today's topic is laws of photoelectric effect. Okay, and summarize. This is important for the 3 marks. Okay, the heading is that summarize experimental study of photoelectric effect. In the last class, we discussed the experimental study of photoelectric effect. Experimental study of photoelectric effect that we discussed in the last class. Then it's a summary I am going to explain now. Summary I am going to explain. Right? And now anyone can give the clarification whether my voice and everything is clear or not. Audio and writing. Okay. Everything clear. Summarize experimental study of photoelectric effect, or this is also called as laws of photoelectric effect. Laws of photoelectric effect. Okay, from that experiment they gave the some laws. Okay, right. This is our heading. From the experiment we can write these all things. Right. Okay, thank you. Voice and picture is clear. Okay, now I am going to continue and you listen very carefully. Today's topic is very important and this is very important for the 3 marks. And now let us start. What are the summarize? Summary is what? Actually, this summary you can read, you got from yesterday topic in the last topic, that is experimental study of photoelectric effect. In that we discussed a few factors. That few factors I am giving the conclusion for that. Okay, right. The first point is that photocurrent is photocurrent. You know photocurrent, right? Photocurrent on what factors it depends? Can anyone write in chat box? On what factors the photocurrent will depends? Photocurrent on what factors it depends? Good morning to all. Right. Photocurrent depends upon photocurrent depends upon intensity of incident radiation. intensity of incident radiation. We done some graphs and some result we gave. From that result, we are giving some conclusions. Photocurrent depends upon intensity of incident radiation, and it is independent of, but it is independent of frequency. Independent of frequency. The frequency of incident radiation. Frequency of incident radiation. On what factors the photocurrent depends? Right, the photocurrent depends upon the intensity of incident radiation. Photocurrent directly proportional to the intensity. We drawn the graph also that it is straight line passing through the origin. But the photocurrent is independent of frequency of incident radiation. This will happens when frequency of incident radiation is greater than threshold frequency. Then only photoelectric effect occurs. This is the first law. These laws are again explain. I will explain. Okay, and that are explained by the Einstein scientist. He explained these laws. At that moment, again I will explain these laws. And the next one is the stopping potential. Stopping potential. Stopping potential and maximum kinetic energy. Maximum kinetic energy. Stopping potential and maximum kinetic energy of photoelectrons. What are the photoelectrons? In photoelectric effect, if electrons are releases that are called as the photoelectrons. Stopping potential and maximum kinetic energy of photoelectrons depends upon frequency of incident radiation. Frequency of incident radiation. But they are independent of intensity. Right? This is the second law. What we are telling it here, there is a formula is there for the maximum kinetic energy. Do you know? Maximum kinetic energy of empty electrons. Right? In the last class we discussed. This is EV naught. There is one more formula is also there. H of nu minus nu naught. Then from this, the maximum kinetic energy is linearly depends upon the frequency of incident radiation. You see here, E is the electron charge in this. Electron charge. V naught is the stopping potential. V naught is the stopping potential. Okay. H is the Planck's constant. This equation you know already. In last class I said. And here explanation also I will give in the today only, right, in the continuation, because these laws are explained by Einstein. Nu is the frequency of incident radiation. Frequency of incident radiation. Okay, you are mentally ready. I will continue the class up to 10:45. And nu naught is the threshold frequency. These are the terms. From this, we say that maximum kinetic energy is depends upon the frequency, and stopping potential also depends upon the frequency. You see here, maximum kinetic energy depends upon frequency, and stopping potential also depends upon frequency, and that is also linear dependence. Maximum kinetic energy depends upon the frequency, and stopping potential also depends upon the frequency, right? That is the second law. But that are independent of what? Intensity. Photocurrent depends upon intensity, but independent of frequency. But stopping potential and maximum kinetic energy of electrons depends upon frequency, independent of intensity. That is the reverse. Okay, this is the second law. And more two laws are there. You take the screenshot and note it. And everyone should continuously stay in the class. And peer group leaders request all the other members to join in the class. Okay, I'm going to erase this. Next, third law. Third laws of photoelectric effect is what? The third law is that if the frequency of incident radiation, okay, if the frequency of incident radiation, if the frequency of incident radiation below certain value, below certain value called as threshold frequency, threshold frequency, no electron emitted from the metal surface, no electron emitted from metal surface. This is the third rule. What is this? If the frequency of incident radiation less than or equal to threshold frequency, frequency of incident radiation below certain value called the threshold frequency. If the frequency of incident radiation nu is below certain value threshold frequency, if the frequency of incident radiation is below threshold frequency, whether electron emits or not emits, okay, electron not emits from the metal surface, is it right? Electron not emits from metal surface means photoelectric effect does not occurs, right? Electron not emits from metal surface, that means photoelectric effect does not occurs. This is the thing that we are giving it here. Next, fourth point is that there is no time lag. There is no time lag between. There is no time lag between incident photon, incident photon, and emitted electron. There is no time lag between incident photon and emitted electron. That means that means photoelectric effect is photoelectric effect photoelectric effect is instantaneous process. What is that? Instantaneous process. What is instantaneous process? Okay, I will explain this. What I am giving in the fourth point. The fourth point is that there is no time lag between the incident photon and emitted electron. That means, what is this? Here you see, when the light falls at here, what light travel in the form of energy packets. This is a light, and these are the photons. And when photons are incident on the metal plate, okay, when the photon is incident on the metal plate, immediately electron will comes out from the metal surface. There is no time gap between the incident photon and emitted electron. There is no time. For example, light is incident, after 1 hour electron emits, like that. Gap is not there. There is no time gap between the incident. Time lag means lagging only, that one. There is no time gap between the incident photon and emitted electron. There is no gap between the incident photon. Light is incidenting means photons are incidenting. Each photon has energy h nu. Okay, that the incident photon and emitted electron occurs simultaneously, instantaneous process. Okay, the time will be nearly zero, 10 to the power of minus 9 seconds. 10 to the power of minus 9 seconds means it is nearly zero, right? Then there is no time gap between the incident photon and emitted electron. And the next one is this is about the four laws of photoelectric effect, but these laws are not explained by the wave theory. Okay, this is important. The question in the different format they will ask, answer you know, but even you cannot understood sometimes the question. The above laws, the above laws of photoelectric effect, the above laws of photoelectric effect, the above laws of photoelectric effect not explained by wave theory of light. You know wave theory, right? Light travel in the form of wave. That wave theory of light not explains, okay, these laws. Okay, these laws are not explained by the wave theory. That means light travel in the form of wave, we know that one. That wave theory not explained by considering the light as wave, we cannot explain these laws. Okay, this is completed. The next we will continue, and you take the screenshot. And that is next one topic is quantum theory of light. You take the screenshot and note it. Okay, let us continue now. That is, I am going to explain the quantum theory of light. Okay, quantum theory of light. What is the quantum theory of light? You listen very carefully. Quantum theory of light. Right? If you have any doubt, you can test. Don't leave from the class. Very important topic we are going to discuss. Right? What is quantum theory of light? That is according to quantum theory. According to quantum theory. According to Einstein quantum theory, what happens? According to quantum theory, light travel, light travel in the form of energy packets, in the form of energy packets. Light travel in the form of energy packets. Are these energy packets also called as quantas? They are called as quantas. Okay, and these quantas are named by this Einstein. Okay, these quantas are called as these quantas are called as photons. They are also called as photons. Actually, it taking the time to write the notes. That's why in this time you also by listening you can write the notes. Then no need to maintain the separate time. No need to spend separate time for writing. Okay, you also try to write at the same time. Okay, right. And now let us see what is the quantum theory. According to the quantum theory, the light travel in the form of energy packets are the quantas. These quantas are called as photons. Now let us see if nu is the frequency of incident light. If nu is the if nu is the frequency of incident light. If nu is the frequency of incident light. If nu is the frequency of incident light, Then, for example, you see here one light ray is falling on the metal plate. This is a metal plate, and the light ray is incidenting on the metal plate. Okay, look at here like this, and you know that the light travel in the form of energy packets. That means light travel in the form of energy packets. These are the energy packets. Okay, these energy packets also called as the quantas, and they are also called as the photons, right? And now this, if this light has the frequency nu, if this light has the frequency nu, then what is the photon energy, right? And that I'm going to explain. You see here, light travel in the form of photons, energy packets. That energy packets is called as photons. And now here, the in the quantum theory, light is considered as the particles. Light considered as particles. Student, network problem, is it the problem is with me or you? Can you clarify? Twinkle and Sushmita. Now, whether the my voice and picture, is it clear or not? Energy of incident photon I want. Light travel in the form of photons. And what is the energy of incident photon? Energy of incident photon. Energy of incident photon is E is equal to, we have the formula, that is H nu. This is the formula for the energy of incident photon. Okay, this is equation 1. Let us consider. And according to Einstein theory, right? According to Einstein theory, we know that energy formula we can also write as, right? Energy formula we can also write as mc square, right? Equal to mc square. These are two energy formulas, and from this we can write mc square equation. From equation 1 and 2, we write one thing: mc square is equal to h nu. We can write from this mc is equal, we write as h nu by c. We can write why mc square we write as mc into c. When c goes to right side, then you will get mc equal to h nu by c. This is equation 3. What is mc? Mass into velocity. It will give the momentum. Okay, the momentum formula is h nu by c, right? This is equation 3. This is the formula for the momentum of photon. Okay, have you understood? If you have any doubt in the next step, you can ask me. Momentum of photon formula is, h nu by c. Energy of photon formula is, right? Energy of photon formula is h nu. Momentum of photon formula is h nu by c. And but we know one thing: speed of light formula. Speed of light formula we know, c is equal to nu lambda. C is equal to nu lambda. That you substitute in above equation, then we will get the momentum of photon is. How you will get the momentum of photon, right? Momentum of photon we will get is h nu by c, but we know already h nu by c. Okay, but what I have to do it here, c we can write as nu lambda. If you write c as nu lambda, then you will get as h nu by nu lambda. This will cancel. Then you will get h by lambda. That means there are two formulas are there for the momentum of photon. Okay, momentum of photon formula is one formula h by lambda. Okay, P is equal to one more formula you got is h by lambda. Lambda is the wavelength. H is the Planck's constant. Okay, till now what we discussed it here. Light travel in the form of energy packets. That energy packets are called as the photons. That photon energy is h nu. Photon also has the momentum. That means that is h nu by c, right? Okay. And you have to remember the photon energy and photon momentum formulas. I'm going to erase. You take the screenshot. Right, let us start. What we are discussing it here? Momentum of photon. I am continuation. Continuation. Right, energy of photon. What you got here? Energy of photon. What you got? Energy of photon. Tell me. Energy of photon we got is h nu. And what is it? What you got? The momentum of photon. Right, momentum of photon. What you got? Can you tell? Energy of photon formula. H nu got. Momentum of photon we got is right. H nu we can also write as nu equal c by lambda. Also we can write c by lambda. Also we can write, because we know c is equal to nu lambda. From that we can write momentum of photon formula. One you got as h nu by c, and other you got as h by lambda. These formulas you should remember. Okay, these formulas you should remember. Momentum of photon and energy of photon. Next, one more formula I will give. That is energy of photon. We have energy of photon, right? Energy of photon, what you got, equal to h nu, but nu equal to what we can write, c by lambda. C is the speed of light. Okay, but h is the what, Planck's constant, 6.625 into 626 into 10 to the power of minus 34 joule second we write. C is the speed of light, 3 into 10 to the power of 8 meter per second, and you multiply both of them, hc you will get. Then convert that hc into electron volts. Then you will get finally 12,400 electron volt angstrom hc value. Okay, or otherwise you already I gave this one in the work function also, right? hc value you should remember, hc product. Okay, unit also you should remember, and hc in nanometers also if you want we can write. Okay, 1240 electron volt nanometers we write. And here energy formula we can write like this: hc, hc we write as 12,400 electron volt angstrom you can write. And if you write the lambda in angstroms, okay, while using the lambda in angstroms if you write, then you will get the energy in electron volts. Okay, right, this formula you may use. That is it for the energy of photon. Okay, energy of photon is equal to c by lambda. You have to take HCI is 12,400 electron volt angstrom, but energy unit is electron volt. When you will get the electron volt energy unit, for example, if you write lambda in angstrom set here, Hc by lambda is the formula. Hc value is 12,400 electron volt angstrom. If you write lambda in angstroms, then this angstrom will cancel, and energy you will get in, right, in electron volts. Okay, while using above formula, while using above formula, lambda must be in lambda must be in angstroms. Remember it. Lambda must be in angstroms. This you should remember. Which formula? This formula. Above formula means. Okay, right. And this is about quantum theory of light. And the next one is, for example, if you want to find out the one question I will give for this related to this. For example, energy of photon they are asking to find out. Example I will give one question. That is energy of photon which has a wavelength. Energy of photon which has wavelength 6 into 10 to the power of minus 7 meters. Okay, and the wavelength of light they gave, they are asking to find out the energy. Then how we can find out? You see here the wavelength they gave is 6 into 10 to the power of minus 7 meters. They are asking to find out the energy of photon, right? Then how we can find out the energy of photon? The energy of photon, we have many formulas, right? We will use equal to h nu. We don't know new value. Don't use new. Hc by lambda we can use. You can substitute the h value, c value, lambda value. It is making somewhat difficult for you. I will give hc value. We can write as 12,400 electron volt angstrom when you write lambda in angstroms. Okay, this formula you can use, but the condition is that uh, lambda must be in angstroms. For that, what you have to do? You have to convert that into angstroms. Then how we can convert angstroms? You know that 1 meter equal to how many angstroms? 10 to the power of 10 angstroms. 1 meter equal to. Okay, 1 meter equal to 10 power 10 angstroms. And 1 angstrom. Then that we can write here 10 power 10 angstroms. Then at the moment, what you will get lambda value? Lambda value you will get as 6,000 angstroms. Okay, this you substitute in above equation. Then what you will get? 12,400 electron volt angstrom by 6,000 angstroms we will get. This angstrom will cancel. Okay, then remaining is two zeros will also cancel. Then 124 by 60 will remains. 124 by 60, what you will get? That you will get is 6 10 ja, 6 2 ja 12. What you will get here? Can anyone give the answer? 620 is 120. 20 point remaining is what? Oh, 40 will remains. 6 6 ja we will get. Then we write 20.6 by 10. We write as 2.06 electron volt. Have you understood? You write in test. You write. Okay. This is how to find out the energy of photon of wavelength 600 to the power of. Here they may ask that find the energy of photon. Find energy of photon which has the wavelength. Okay. 600 to the power of -7. Right answer is completed. Have you understood everything? Is it clear, students? Right. Now I am going to continue. I am going to start the important topic. Right. And next one is I am going to erase this total. Have you understood? Do you have any doubt? Can you tell? Do you have any doubt in this? I am going to erase total and then I am going to start. The next one is the next topic is the intensity of light. Is it clear till now? Right. Okay. Bhumika, Sushmita, no doubt. Okay. Thank you. Next, I am going to continue. That is next topic is the intensity of radiation. How to find out the intensity of radiation? What is the intensity of radiation? Intensity of radiation. Intensity of radiation means what? Okay, what is intensity? We also discussed the intensity word in electromagnetic wave chapter also. In we also discussed the same term in the wave optics chapter also, right? And now again, once again, I am going to explain the same definition will be there everywhere. Okay, energy radiated. The energy radiated means emitted. Okay, energy radiated means emitted per unit time, per unit time, and per unit area, and per unit area is called as intensity of radiation. Okay, this is the intensity. Now, what is the formula for the intensity of radiation? Right, it was very simple. That is intensity is equal to energy radiated, energy emitted per unit time, per unit area is called as the intensity. Okay, then intensity we write as energy, we write as E, that is energy by time into area. Okay, but energy by time we can also write as the power, right? Because energy by time is the work by time, energy equal to work, work by time is the power. That this formula we can also write as the power by area. Is it right? Okay, intensity equal to energy by time into area, or otherwise power by area. We can also write like this. And SI unit of intensity we know that as watt per meter square. What is the SI unit? Watt per meter square, right? Watt per area is meter square. Now next continuation, right? Ask other students to come in the class. Oh, right, increase the size of the writing. Okay, I will increase, don't worry. Actually, I have the zooming option also. Now, is it okay? Little bit I increased. Okay. Now, I'm going to continue. Energy radiated per unit time per unit area is called as intensity of radiation. Intensity equal to energy by time into area. The energy by time is also called as power. Power by area. But in case of light, in case of radiation, right? In case of light or the radiation, light is also called as radiation. Light is electromagnetic radiation, right? Light is an electromagnetic wave. And now in case of light, then power we can write as, okay, power, energy we can write as energy. For example, the light has n photons. If the light is falling at here, okay, the light is falling on a metal surface. If this light has falling n photons falls on metal surface in time small t, okay, and now each photon has energy h nu, then n photons energy is nh nu. Is that right? Light is falling like this on a metal plate. When light falls at here, energy what we can write? Energy of light we can write like this. Energy of light is equal to, we write as, if n photons falls at here, then n into h nu we write energy in time t, where n is the number of photons incident in time t. Number of photons. N is the number of photons. Then we can write intensity is equal to energy by time into area. But energy is what here? Energy is nh nu. Is that right? Energy is nh nu. N photons energy is nh nu. One photon energy is h nu. N photons energy is nh nu. Right? Now light has n photons means nh nu we can write. By time into area we write. And from this equation, write one thing, that intensity is directly proportional to the number of photons, right? Intensity is directly proportional to the number of photons. If intensity is more means what? Number of photons is also more. If intensity is more, then number of photons is also more. If intensity is more, if intensity is more, then number of photons also more. Number of photons is more. If intensity is less, the number of photons is less. This is the intensity is linked with the number of photons. Okay, if you increase the intensity, right, only number of photons will be increases. And the next continuation, I'm going to start. That is Einstein explanation of laws of photoelectric effect. Next topic is the Einstein explanation of photoelectric effect. Very important topic, right? Okay. And for before that, Einstein photoelectric equation I will explain. Einstein photoelectric equation, right? This is also very important. Einstein photoelectric equation. Einstein photoelectric equation. What is Einstein photoelectric equation? Okay, right. Let us start. Einstein photoelectric equation. And if you have any doubt, you can test, right? And now let us start Einstein photoelectric equation. And now, for the purpose, Einstein explained the photoelectric effect. Einstein explained photoelectric effect. Photoelectric effect. Einstein explained the photoelectric effect based on quantum theory, right? Based on what? Based on quantum theory. Based on quantum theory. When a photon is incident on a metal surface, when a photon is incident on a metal surface, each free electron, each free electron absorbs absorbs one photon. Energy of photon, energy of photon used in two ways. Used in two ways. The first one is the part of energy, part of energy used to liberate, part of energy used to liberate an electron, part of energy used to liberate an electron from metal surface. I will explain, don't worry. It is called as the work function. It is called as the work function. And the second point is the remaining photon energy, remaining photon energy used as or the converted into remaining photon energy converted into maximum kinetic energy of emitted electron, maximum kinetic energy of emitted electron. Okay, I will explain now whatever that sentences I will give. I explain. I gave now something that this is the other points I will explain now. Okay, are you listening any background music? Something, some disturbance is there? Are you? Do you have any disturbance? Is it clear voice? One second, I am coming. Right. Okay, now the remaining photon energy converted into maximum kinetic energy of empty electron. You listen very carefully, and the point that I am going to explain. This is a metal plate. This is a metal plate, and now the light is incidenting on the metal plate. Look at here. This is the light. Okay, this light travel in the form of energy packets, and these are the energy packets. Okay, that are incidenting on the metal plate. The energy packets are called as the photons, and each photon has the energy h nu. Like this, the photons are incidenting on the metal plate. Okay, and now in the metal plate we have so many electrons, right? Metal is the conductor, it has many free electrons. Okay, and what we are telling here, how according to Einstein, Einstein explained that photoelectric effect based on the quantum theory. When a photon is incident on a metal surface, look at here, this is the metal surface. Now photon diagram, you see cursor is very important. When photon incident on the metal surface, light incident on the metal surface, each free electron absorbs one photon. Look at here, here one electron is there. One electron absorbs the photon. Photon means what? It's energy, energy packet. It's a energy. That energy is absorbed by the electron. Then after absorbing, what it will do? That energy of photon is used. Energy of photon used in two ways. This electron absorbs the photon. Means this electron absorbs the photon energy. After absorbing the photon energy, it can be used in two ways, right? Who is absorbing the photon energy? Electron absorb. Right? After absorbing the photon energy, one photon is absorbed by one electron. That means h nu energy absorbed by the electron. It can be used in two ways. How they are using? Part of energy used to liberate. Part of energy used to liberate. That means just to come out from the metal surface, just to come out from the metal surface. Okay, electron came out. Now electron came out. For that, how much energy used? That energy used is work function, right? Energy used is work function. And after that, what it will do? Part of energy used to liberate. Actually, from the metal surface to come out the electron, some energy required. That energy is the work function. After that, the remaining energy used is the maximum kinetic energy of electron. Okay, that I will explain clearly now. You see here with the example. Okay, for example, one photon has the 5 joules energy. One photon has the 5 joules energy. Just 5 electron volts energy. Example, let us consider. And now this is incidenting. And in that photon is absorbed by the electron. Now this electron, part of energy used out of 5 electron is absorbed by the electron. 5 electron volt energy is absorbed by the electron. This is the photon. H nu is the photon absorbed by the electron, right? Because photons are incidenting on the metal plate. This electron, part of energy used to come out. That means, for example, 3 electron volts is used to come out from the metal surface. That is the pi naught. Right? The remaining energy is what? Total 5 electron volts is absorbed by the electron. Out of 5, 3 is used to come out, and the remaining is the 2 electron volts that will converted as maximum kinetic energy of electron. This is Einstein explanation. Right? What happening at here? हिंदी में एक बार एक्सप्लेन करता है, देखिए एक्चुअली क्या कर रहा है, लाइट इधर इंसिडेंट हो रहा है, इस लाइट एनर्जी पैकेट तरीका ट्रैवल करता है, एक एक इलेक्ट्रॉन मेटल में इलेक्ट्रॉन्स होता है, एक एक इलेक्ट्रॉन एक एक फोटॉन को ऑब्जर्व करता है. अब फोटॉन को ऑब्जर्व कर रहा है मतलब फोटॉन एनर्जी को ऑब्जर्व कर रहे हैं. फोटॉन एनर्जी को ऑब्जर्व करके दो तरीका यूज करता है. राइट? फोटॉन एनर्जी क्या है? एच न्यू ऑब्जर्व करके पार्ट ऑफ एनर्जी, राइट, में कुछ एनर्जी, एच न्यू में कुछ एनर्जी बाहर आने के लिए यूज करता है, उसको वर्क फंक्शन बोलता है. बाकी एनर्जी काइनेटिक एनर्जी फॉर्म में कन्वर्ट होता है. दैट मींस अकॉर्डिंग टू लॉ ऑफ कंजर्वेशन ऑफ एनर्जी क्या कर लिख सकते हैं हम लोग? According to law of conservation of energy, that incident energy is what? H nu. Incident energy is H nu. H nu energy is incidenting it here. Then part of energy used, this will be utilized in two ways. Part of energy used to come out from the metal surface, that is phi naught, and remaining energy used as the maximum kinetic energy. that is Ke max. Have you understood? 5 electron volts is there here. Okay, 5 electron volts is absorbed by the electron. H nu is the 5 electron volts. Let us consider that 5 electron volts is absorbed by the electron, and 3 electron volts used as to come out from the metal surface. The minimum energy used to come out from the metal surface is called as the work function. Energy used in two ways. Part of energy used to liberate an electron from metal surface, just to come out from the metal surface. The minimum energy required to come out from the metal surface is called as the work function. That's why this is called as the work function. The part of energy used to come out from the metal surface is called as the work function. And the remaining energy used as kinetic energy. Let me see. From this we write H nu is equal to phi naught plus Ke max. This equation is called as the Einstein photoelectric. This is the Einstein photoelectric. Okay. What is this? This is called as Einstein photoelectric equation. Einstein photoelectric equation. Okay. Right. And now in this, let us see here. We will write one formula for the phi naught. But phi naught is what it here? What is new in this? We write some terms. New is what? Frequency of incident radiation, right? What is new? Frequency of incident radiation. Any doubt? Phi naught is what? Work function. Phi naught formula we know H nu naught. It is a work function. That H nu naught is what? Threshold frequency. Nu naught is what? Threshold frequency. Okay. Phi naught is the work function. And Ke max is what? Maximum kinetic energy. Is that right? Maximum kinetic energy of electrons. Is it clear, students? What happens with the kinetic energy? With the kinetic energy, the electron moves. That moving electron can be used for the current. The moving electron can generate the current. That means in the generation of current, we can use this, right? Aditi, that is the answer for that. Now, this is the maximum kinetic energy of electron. Next, I am going to continue. You take the screenshot and note it. Okay, continuation. We know Einstein photoelectric equation, right? But phi equal to phi naught we write as h nu naught. Then by using that we write like this h from Einstein equation, from Einstein photoelectric equation, right? From Einstein photoelectric equation. What is Einstein photoelectric equation? You should remember Einstein photoelectric equation. Einstein gave that equation, right? Einstein photoelectric equation is h nu is equal to, here we got what? Phi naught plus h nu naught. Phi naught plus Einstein photoelectric equation is phi naught plus Ke max. But phi naught is the work function. Its formula is h nu naught. Then we write Ke max. Then from this maximum kinetic energy of empty electron of formula also we can write. What we write from the maximum kinetic energy of empty electrons? Right? Ke max is equal to, we write as h nu minus h nu naught. Then from this Ke max formula we will get as h of nu minus nu naught. This is the formula for the maximum kinetic energy of empty electron. What is the Ke max in this? Maximum kinetic energy of empty electron. What is H? Planck's constant. What is nu? Frequency of incident radiation. What is nu naught? Threshold frequency. Okay. Okay, this is about Einstein photoelectric equation. In this, what happening in the photoelectric effect? When the light of frequency nu incident on a metal plate, the light has energy packets. Then they are called as the photons. That energy packet, one packet is absorbed by the electron, and this electron comes out from the metal surface. After coming, and it can go with some kinetic energy. That this phenomenon is the photoelectric effect. Next topic, Einstein explanation of photoelectric effect. I am going to erase this. Take the screenshot. Any doubt till now? No doubt now? Okay, let us start. And the next topic is very important. That is Einstein explanation of laws of photoelectric effect. How Einstein explained the laws of photoelectric effect? Einstein explanation. Einstein explanation of laws of photoelectric effect. There are four laws in the beginning of today's class we discussed. Right? Einstein explanation of laws of photoelectric effect. Okay? Einstein explanation of laws of photoelectric effect. How Einstein explained the laws. Right? Let us start. For that, what are the laws? Right? Einstein explained based on the quantum theory. What are the laws of photoelectric effect? Do you know laws of photoelectric effect? First law is that photocurrent is directly proportional to intensity of incident radiation. Photocurrent is directly proportional to intensity of incident radiation. If intensity increases, photocurrent increases. Then how this point is explained? Right? Listen very carefully. Okay, I'm going to explain these all things very carefully. I will explain. You also listen very carefully. Right? If the with the notes I am explaining that if the intensity, if the notes is not there, then it will not take this much time. You don't feel that sir is taking much time. Actually, due to the writing all things, it is taking much time. If I will explain, it will not take the time because I am doing the simultaneously two works, explaining and write giving the notes. That's why it is taking the much time. Okay. If intensity of incident radiation, if intensity of incident radiation is increased, okay, then according to quantum theory, according to quantum theory, according to quantum theory, number of photons, number of incident photons, number of incident photons, also number of incident photons increases, right? Then number of emitted electrons, then number of photoelectrons, the number of electrons emitted from, with the writing also you can understood. No need of explanation. It is very easy. Number of electrons emitted from metal surface also increases. So photocurrent increases. Photocurrent increases. This is the first law explanation. What is this? The first law is that photocurrent is directly proportional to intensity. Right? This is the thing. Therefore, photocurrent linearly changes with intensity of light. Okay, right? The graph also you will get like this. Photocurrent is taken on y-axis, intensity is taken on x-axis. You got the graph like this. Is it right? Previously we discussed. This is x-axis, this is y-axis, right? Photocurrent is taken on y-axis, intensity is taken on x-axis. You will get like this. This is the explanation of the first law. What is the first law? First law is that photocurrent directly proportional to intensity. Photocurrent depends upon the intensity of light. Okay, I will explain now once. If the intensity of incident light increases, for example, intensity of light increases. Intensity increase करते तो क्या होता है? If intensity of incident light increases, then intensity directly proportional to number of photons. Do you know that? When intensity increases, then automatically number of photons increases. Actually, one photon can emit the one electron only. One photon emits the one electron because, for example, one photon energy, one photon is incidenting. Then one electron absorbs the photon energy and comes outward and moves with some kinetic energy. That means to emit one electron, one photon is required. If many photons are there, many electrons will emit. Is it right? Many photons emits means many electrons will emit. If more electrons means more current. Current generated due to the photoelectrons is also depends upon the current formula charge by time. Charge depends upon the number of electrons. If number of electrons increases, current also increases. That means, according to Einstein, when intensity increases, number of photons increases. When number of photons increases, number of emitted electrons also increases. When number of emitted electrons increases, then automatically current increases. That means, firstly, what we are increasing? We are increasing the intensity. With that, what is increasing? Number of photons increasing. With the number of photons, what increasing? Number of electrons increasing. With the number of electrons, what increases? Current increases. Right? That means when intensity increases, photocurrent also increases. Have you understood this point? Very easy. Right? And next one. Second point. Second point is that from Einstein equation. Okay, from Einstein photoelectric equation. What you know? From Einstein photoelectric equation. From Einstein photoelectric equation, what we write, that is incident photon energy h nu is equal to, we write as phi naught plus ke max we write. From this ke max formula we derived, right? Ke max formula what you got? H nu minus h of nu minus nu naught. Is it right? This derivation just now I told, right? And why, how you got this derivation, this equation? Because we know phi naught formula is a work function formula h nu naught. Previously we discussed this about this one. Phi naught formula is h nu naught. Right, let us see here. And now what we have to do it here? We have to K max formula we know h of nu minus nu naught. This formula we derived just now. K max one more formula is also you know. From this K max is equal to, we know this we can write like this, h nu plus minus of h nu naught we write. Just very simple, from this only we will get. Phi naught is equal to h nu naught. Okay, this you know, and this is I substituted here. K max formula we got like this. This is similar to the y is equal to mx plus c equation. Right? It is similar to the y is equal to mx plus c equation. Yes or no? It is similar to y is equal to mx plus c equation. Is it right? It is similar to y is equal to mx plus c. It is similar to y is equal to mx plus c equation. Right? Do you know y is equal to mx plus c? Right? Y is equal to mx plus c indicates a straight line. Right? It will intersect the y-axis. In this, y is equal to mx plus c, where m is the slope and c is the y-intercept. You learned in the straight lines in the mathematics. Right? Mm, now we draw the graph between the maximum kinetic energy and maximum kinetic energy and frequency. Frequency is taken on y-axis, and the maximum kinetic energy taken on y-axis. Then what you will get? You will get the graph like this. Why? When you will increase the frequency, right side it will goes. When you will increase the frequency, when you will increase the frequency, what happens? Then maximum kinetic energy also increases. You see this equation. Nu is the frequency of incident radiation. When the frequency increases, then the kinetic energy also increases. When the kinetic energy increases, then you will get the graph like this. Frequency increases. When you will go to right side, frequency increases. When frequency increases, then automatically what happens? Kinetic energy also increasing because it is going up. You will get the graph like this. And now in this, what the slope of this graph indicates? Slope of graph indicates. Slope of graph is the m. It indicates. Okay. Slope of graph is the y is equal to mx plus c, where m is the slope. Then m is what it here? Slope of graph gives the h. H means what? Planck's constant, right? Okay, from the graph we can find out the Planck's constant. And y-intercept, you can do the extension at here. You can do the extension like this for the graph. When you will do, it is intersecting the y-axis. This y-intercept is called as the, this y-intercept is called as c. Okay, then c is equal to, from the figure what c? C is the minus h nu naught, y is equal to mx plus c. C is the h nu naught, right? C is the h nu naught. H nu naught, what it will give? It is the phi naught. Phi naught means what? Work function. That means from maximum, from the graph, what we can find out? From the graph, we can find out the slope, that means Planck's constant. We can also find out work function. Okay, right. The next, actually, second law is what? Actually, whether I want to explain the second law. Then for that, I am going to erase this. You listen very carefully. Whether my voice is clear or not. Actually, I kept the mic to a side till now, and I am teaching. I forgot that. Nobody is telling that there is some little bit disturbance in the voice. There is no disturbance in the voice till now. I kept the mic to a side actually. I forgot. I went outside for the 1 second. In that time, at the time, I removed the mic. Then after returning, then I am not using the mic from that time onwards. Now I kept the mic. Right? Is there any doubt? Let us see here. Let us continue. Okay, let us start. What is we are telling it here? Previously, maximum kinetic energy formula we got is maximum kinetic energy of electron formula. What you derived, right? Maximum kinetic energy of electron formula is we derived as h of nu minus nu naught, and maximum kinetic energy formula is also we know ev naught. Then ev naught is equal to we write as h of nu minus nu naught. What is ev naught? Stopping potential. You know this very well. About maximum kinetic energy formula is ev naught. This we derived in the last. Is it okay now? Wait for few seconds. Here you see the maximum kinetic energy is h of nu minus nu naught, and ev naught is equal to h of nu minus nu naught. From above equations we write stopping potential and maximum kinetic energy Maximum kinetic energy depends upon nu. Stopping potential V naught also depends upon nu. Maximum kinetic energy from above equation, stopping potential and maximum kinetic energy depends upon depends upon frequency of incident radiation, frequency of incident radiation, but independent of intensity, right? Independent of intensity. This is the explanation of second law. The second law is what? The second law of photoelectric is kinetic energy depends upon frequency. We proved that one. Stopping potential also depends upon the frequency. We proved that one. Okay, maximum kinetic energy depends upon frequency of incident radiation, but independent of intensity. We completed, and now I am going to explain the third law of photoelectric effect. What is the third law of photoelectric effect? Third law is that can you tell what is the third law? If the frequency of incident radiation below the certain value, for example, we know maximum kinetic energy of empty electron. Actually, kinetic energy is always positive. Maximum kinetic energy of emitted electron must be greater than or equal to zero. Kinetic energy never be uh, less than zero. It will not negative. That's why kinetic maximum kinetic energy formula always greater than or equal to zero. And then we can write here like this maximum kinetic energy formula previously we know. Then h of nu minus nu naught we write as greater than or equal to zero. Then from this we will get nu greater than or equal to nu naught if you simplify. That means this is the condition for the photoelectric effect occurs. If this condition is not satisfied, then photoelectric effect not occurs. This is the condition to get the photoelectric effect. If nu less than the frequency of instant radiation less than threshold frequency, then photoelectric effect not occurs, right? Why? If you take the nu less than maximum kinetic energy formula is what? You know that h of nu minus nu naught. If nu greater than nu naught, then only maximum kinetic energy positive. Otherwise, what happens? From this nu minus nu naught greater than or equal to zero, we write. Then nu greater than or equal to nu naught, we write. Minus nu naught, you take to right side, you will get this one. That means photoelectric effect, occur the photoelectric effect, this is the condition. Okay. That means if this condition is not satisfied, then photoelectric effect not occurs. Photoelectric effect not occurs. Okay, right. That means therefore we write like this. This is the proof for that. If nu less than nu naught, what happens? If nu less than nu naught, you see this maximum kinetic energy formula cursor. You should have to ask. If nu less than nu naught, then if less value minus more value gives the what happens? Negative kinetic energy. Negative kinetic energy is not possible. Either kinetic energy zero or positive, but negative kinetic energy is not there. There is no object which has negative kinetic energy. That's why, right, nu always greater than or equal to nu naught. If nu less than nu naught, then kinetic energy negative, but kinetic energy negative not possible, means photoelectric effect not occurs. If the frequency of incident radiation, the frequency of incident radiation, if frequency of incident radiation, if frequency of incident radiation below certain value, below certain value called threshold frequency, threshold frequency, no electron emitted from the metal surface. No electron emitted from metal surface. Okay, right. Next, fourth point is that electrons are liberated instantly when photons are absorbed. Electrons are liberated instantly after observing photons. Hence, there is no time lag. Hence, there is no time lag. There is no time lag between incident photon, and emitted electron. Okay, these are the explanation of laws of photoelectric effect. Previously, we discussed the four laws. The four laws explained now. Now, last, I will close the topic earlyly. Okay, before 5 minutes only. That means no, not before 5 minutes. More 5 minutes only. I will continue, and after that I will close. Don't worry. Okay, I will take the class up to 10:30 or 10:35 only. Right? Okay, I'm going to erase this. We are in the ending. Einstein explanation also completed. Next. Next one is side heading note some point I am going to give. You got the formula for the maximum kinetic energy of empty electron from the according to Einstein photoelectric equation. Maximum kinetic energy of empty electron. Can you tell? Maximum kinetic energy of empty electron is what? Ke max is equal to h of nu minus nu naught, right? H of nu minus nu naught. But Ke max formula is what? In terms of stopping potential? EV naught. We substitute in above equation. Then EV naught is equal, we will get as h of nu minus nu naught. Then V naught is equal to what you will get? H by E of nu minus nu naught. Then we will get V naught is equal to H by E into nu plus minus H nu naught by EV, right? What is V naught at here? Stopping potential. Stopping potential. Okay. V naught is equal to what we write here? H by E into nu minus H nu naught by EV, right? We can multiply with H by E. This is similar to y is equal to mx plus cr minus c. Okay, these formulas are there. This is a straight line equation. The straight line equation. Straight line, but not passes through origin. Y is equal to mx indicates straight line passing through origin. X is on x axis, y is on y axis. Y is equal to mx plus c indicates straight line, but it will intercept the y axis. It will intercept the y axis. Right? Okay. And now here we are discussing the this graph. Okay, I am going to explain the graph, that is stopping potential versus here y versus x graph होता है, then here v naught versus nu. Okay, stopping potential versus frequency graph. Okay, v naught nu graph means stopping potential versus frequency graph. How you will get? You will take nu on x axis, that is the frequency of incident radiation, and the stopping potential on y axis, that is v naught. Then how you will get the graph? You will get the graph a straight line. You will get the graph a straight line like this. You will get. Why? When nu increases, v naught also increases. You go right side, you see. When you will go to right side, the nu increases. Then the curve is line is going up. Means kinetic stopping potential also increases. When nu increases, v naught also increases from this equation. Okay, you watch the cursor. And the next, the minimum value of nu where the stopping potential is zero, right? At a particular minimum value of frequency, right? At a particular minimum value of frequency, stopping potential becomes zero. You see here this point. Y0 means x is there. Y0 means it will intercept on x axis. Then we write like this. Maximum kinetic energy is zero for certain frequency, minimum frequency. That minimum frequency is called as threshold frequency, right? Or the cutoff frequency. This is the threshold frequency. This at this point kinetic energy becomes zero, right? When you will go right side from this will be nu greater than nu naught. It will be nu greater than or equal to nu naught. Here frequency is greater than nu naught. Then at the moment stopping potential will be more, increases. When nu increases, then stopping potential also increases. Then one more point here we write. What we write the slope? Slope of v naught nu graph. What it will gives? Slope of v naught nu graph. You compare these two equations. These two you should compare. When you will compare these two, what you will get? V naught is y, h by e is m, nu is x, this one is c. Then here m will become h by e. Okay, right. Slope of graph gives h by e, Planck's constant by electron charge. Next, you find out the y-intercept. What y-intercept it will gives? Y-intercept of v naught nu graph. What is the nature of the graph? Graph is a straight line, right? Graph is a straight line, but it not passes the through the origin. It will intercept the y-axis. What is the y-intercept value? Y-intercept value is c. C is what here? C is the plus or minus c. H nu naught by c. H nu naught by e. H nu naught is what? Work function. Work function by e. Right? If y-intercept is more, if c is more, then the work function is also more. Right? We can do the like this. This is the y-intercept. This y-intercept, what it is giving? It is giving the h nu naught by e. Right? Okay. This is the class. Practice properly, and more one lecture required to complete this chapter. I thought today it will complete, but whatever that I am expecting on every day, and that is not completing. Okay. Thank you to all for coming to the class and motivate other students to come to the class. Okay. And I'm going to close.